Welcome students. This is my fifth lecture and we are continuing with the chapter Similarity. In the last class, as you are seeing on the board, sum number 6, 7, 8 and 9th were given as homework. I think you could have done these sums easily because all these sums are based on the two properties that we have studied in the last lecture. Property 1, the property of an angle bisector of a triangle. Property 2, the property of three parallel lines and their transversals. Now we are solving sum number 10 and 11 of this exercise, this practice set 1.2. Actually, if you have tried them, it is good. But if you have not solved, let's do them. So students, as you are seeing, in this sum, we are given in triangle DEF, seg PQ is parallel to side DE and seg QR is parallel to side EF. This is given to us. Okay, this is parallel to this and this segment is parallel to this side. We have to prove that segment PR is parallel to side DF. Actually, they have given this answer is in the form of fill in the blanks. Means you have to just fill the blanks and complete the proof. But we will try to prove ourselves. Okay, and you can do that fill in the blank work by yourself. So in the proof, what we will write? We will make use of the given information. The information given is seg PQ parallel to side DE in triangle DEF. Recall, only think about triangle DE, and I forgot to put a point. This is point X there. So just think about triangle DXE, and in this triangle you can see that point P and point Q are on sides XD and side XE. Now a line is drawn parallel to one side of triangle and intersects the other two sides in distinct points. Then we know by BPT that this line divides the other two sides in the same ratio. So ratio XP to PD is equal to ratio XQ to QE. Understand? So what we have to write in triangle, think which triangle you have to consider? XDE. In triangle XDE, which line or segment, we can write anything. Line PQ parallel to side DE. Okay, and why? Because it is given to us. Okay, now because of this, as this satisfies the condition for VPT, we can write XP, ratio of segment XP to PD. As you are seeing, XP to PD is equal to ratio of segment XQ to segment QE. Okay, and what reason we must write? Basic proportionality theorem. In the exam, try to write the full form. Also, we are given similar information, segment QR parallel to side EF. So we will consider now triangle XEF. So similarly, we write similarly because both the statement as we have written here will be repeated here. So similarly, this triangle in triangle XEF. What is given to us? Line QR is parallel to side, which side? Side EF. Okay, reason is given. Therefore, what will be the consequence of this? If you use BPT, the ratio XQ to QE, the ratio XQ to QE will be equal to ratio XR to RF. XR to RF. This is again by basic proportionality theorem, and result number 2. Okay, now see the two results we got. XQ upon QE is equal to XP upon PD. XQ upon QE is equal to XR upon RF. So very simple, by our common sense what we can write. Therefore ratio XP upon PD is equal to the ratio XR upon RF. And this we get from 1 and 2. Result 1 and 2. Okay, because this ratio is same in both the results. Now check out XP to PD. XP to PD is equal to XR, XR to RF. What does this mean? This means that line PR, okay, divides side XD and side XF of triangle XDF in the equal ratio. Okay, so therefore what we will write? Therefore in triangle, which triangle we will now consider? XDF. In triangle XDF, what we have proved? We have proved that XP upon PD is equal to XR upon RF. Why? We have to write, we have to give this as result number 3. So the reason for this one will be from 3. Now check out and use your common sense. In a triangle, if a line divides two sides, any two sides in the same ratio, then that line must be parallel to the third side. So therefore what we will write? Therefore line, which line it is? PR. Line PR is parallel to which side of the triangle? Which side of the triangle? Third side. Third side is side DF. Okay, the reason from this is converse of BPT, converse of basic proportionality theorem. Okay, we have seen here that the two sides are divided in the same ratio by line PR. So line PR is parallel to side DF. That is what we have to prove. So we can write that is seg PR is parallel to side DF. This is how we can prove. Okay. So we have used both the theorems, BPT as well as converse of BPT, to do this sum. It's very simple sum. You have to fill the blanks in the textbook. So you can fill the blanks seeing this proof or by yourself, or you can do this sum as a separate sum. Okay, now we shall move for the next sum, that is sum number 11. So students, you are seeing in 11th sum we are given triangle ABC. Ray BD is bisector of angle ABC. Ray CE is bisector of angle ACB. Point D and E lie on sides AC and AB respectively. Also, side AB is congruent to side AC. That means triangle ABC is an isosceles triangle. We have to prove that segment ED is parallel to side BC. Understand? Now what do you see in the given? Rays BD and CE are bisectors of angle ABC and angle ACB respectively. So whenever such word angle bisector comes, we have to think about the property of angle bisector of a triangle that we have already studied in the earlier lecture. So how will we use the property? In triangle ABC, suppose if you consider only one angle bisector, say ray BD is the bisector of angle ABC, then according to the angle bisector property, the opposite side AC is divided in the ratio of remaining sides of the triangle by this angle bisector. So what do we see? That the two parts of side AC, that is ratio of AD to DC, is equal to ratio of AB to BC. Understand? So this is the angle bisector property. If you consider ray CE as the angle bisector, then the opposite side AB, which is divided into two parts AE and AB, and the ratio of these two parts is equal to ratio of the remaining sides of the triangle. So AE upon AB is equal to AC upon BC. Now with this and even the other given information, that is side AB congruent to side AC, how will you prove this? It's very simple. So we are now writing the proof. We prepared. So students, As I explained, we consider triangle ABC. In triangle ABC, ray BD is bisector of angle ABC. So this is given. So AD upon DC, opposite side of angle ABC is side AC. The two parts in which it is divided are AD to DC. The ratio of these two parts, AD to DC, is equal to ratio of the remaining sides of the triangle. That is the ratio of side AB to side BC, AB upon BC. And I have told you earlier also that with part AD, the corresponding side of the triangle is side AB, and with part DC, the corresponding side of the triangle is side BC. Okay, we have to be very careful while writing such ratios. Reason, property of angle bisector of a triangle. We can also write angle bisector theorem as actually it is given in the textbook. Similarly, we will consider the other angle bisector and write the statement. Write the statement. Come on, you yourself can do. So we can write, similarly in triangle ABC, ray CE is bisector of angle ACB. Ray CE is bisector of angle ACB. Given. Therefore, the opposite side is divided in the two parts AE and EB. The ratio of these two parts AE to EB is equal to ratio of the remaining sides of the triangle. That is side AC upon side BC. We can see this. This is again by property of angle bisector of a triangle. Now in addition to this, what is given to us? Also, we write also side AB is congruent to side AC. This is given to us. Okay, this is given to us, which we may write as result number 3. Now think result 1, 2 and 3. This and this. What can you write with the help of these three results? See, AB congruent to AC. AB and AC make the numerators in these two ratios. They are equal, they are congruent, they are equal. BC and BC form the denominator of the same ratios, which are same. That means these ratios, the right hand sides of the first and second statement are equal to each other. If these are equal to each other, we can also write that the left hand sides of the two statements are also equal. So what we can write? Therefore we can write AD upon DC is equal to AE upon EB. What is the reason for this? From 1, 2 and 3. Very simple. Okay, we got this from 1, 2 and 3. Observe what we got. AD upon DC is equal to AE upon EB. Now do you get some idea here? We see that line ED divides side AC and side AB of triangle ABC in equal ratio. Okay, we proved it here. So what is the meaning of this? Let us give this as result number 4. Okay, therefore what we can write? Therefore in triangle ABC, full triangle ABC, okay, line ED is parallel to side BC. What is the reason for this? From 4th and come on, and converse of basic proportionality theorem, converse of BPT, because line ED divides side AC and side AB in the same ratio, so that line is parallel to the third side. So line ED is parallel to side BC. That is what we have to prove. That is करके हम लिख सकते हैं. That is we can write. That is seg ED parallel to side BC. Hence it is proved. The sum is proved. Understand? Very simple sum it is. The 10th sum is based on basic proportionality theorem and the converse of basic proportionality theorem. This sum is based on the angle bisector property. Very simply these sums are solved. You must try these sums by yourself. Before you see this video, you must try. So this is end of exercise 1.2. Now we will move to see the theory part of practice set 1.3. The theory part is very simple. You have already studied in 9th standard, and that is about the test of similarity. In the 9th standard, you had seen that two triangles can be similar by three different tests. There are three tests of similarity. Okay, this test we will see one after the other, and we'll try to see the few sums of exercise or practice set 1.3. So students, as you are seeing, before we start practice set 1.3, we have to study tests of similarity of triangles. First test I have written AAA test. Full form angle, angle, angle test. You are seeing the diagram. What do you see? You see triangle ABC and triangle PQR looking similar. We see that angle A and angle P are marked to be congruent. Okay, identical marks means these angles are congruent. Angle B and angle Q are marked congruent, and angle C and angle R are marked congruent. These are the minimum conditions, sufficient conditions to prove two triangles similar. Means it is not necessary that we should be given all the different parts to prove two triangles similar, like sides should be in proportion, corresponding sides should be in proportion, and corresponding angles are congruent. Even if we are given that three angles of one triangle are congruent to the corresponding three angles of another triangle, then also the triangles will be similar. There is no need of sides to be given in proportion or in same ratio. So what we write here, we see that triangles are similar by AAA test. Therefore what I will write, triangle ABC is similar to triangle PQR by which test? Angle, angle, angle test. This is the sign of similarity. Okay. Now we know that sum of measures of all angles of a triangle is equal to 180 degree. Now when two angles of one triangle, say angle A and angle B of triangle ABC, are congruent to two angles of triangle PQR, say angle A congruent to angle P and angle B congruent to angle to Q, then suppose this third angle is not given congruent, then what will happen? Third angle will be automatically congruent to each other. Means angle C will be congruent to angle R. Okay, why? Because we know that sum of all angles of a triangle is 180 degree. Now if this is 70 degree, then this is 70 degree. If this is 60 degree, then this will be 60 degree. 70 plus 60, 130. 70 plus 60, 130. So this angle has to be 50 degree. So this is also 50 degree. Therefore, the two angles will be automatically congruent. So even for two triangles, if we are given two pairs of corresponding angles to be congruent, then also the triangles are similar. Okay, so we can also write this test as AA test also. AA test means what? AA test is nothing but AAA test. Even we can say that AA test is a part of AAA test. But here what is the meaning of this? If two angles of a triangle are congruent to corresponding two angles of another triangle, then both the triangles are also similar to each other. So AAA test and AA test are not different tests. We can sometimes use AA test also while solving the problems. So this is the first test of similarity of the triangles. Now we will go to see the second test of similarity of the triangle. So students, you are seeing I have drawn triangle PQR and triangle LMN, and I have written the measurement of the sides, lengths of the sides of the triangles. I have written side PQ is of length 4 unit, side LM is of length 2 unit. These are corresponding sides. If suppose these are corresponding sides, then what relation do we see? We see that half of this side PQ is this side LM. In other words, side PQ is double of side LM. The ratio of these two corresponding sides is 4 by 2. 4 is to 2, that is 2 is to 1. Same relation we find between side QR and side MN. Ratio is 6 is to 3, that is 2 is to 1. Same relation we find between the corresponding sides PR and LN. 5 is to 2.5, 2 is to 1. If this is the case, then what we can say? We can say that the corresponding sides of these two triangles are in same ratio. Okay, we cannot call that these two sides are corresponding sides are equal or congruent, but we have to say that the corresponding sides of these triangles are in the same ratio. Here we see the ratio 2 is to 1. 2 is to 1 for all the pairs of corresponding side. If such is the case, no angles are given, only the relation between the sides is given, then such a test, for like similarity of the triangle is called as side test, SSS test. Okay, please remember side test, okay, is the test for similarity of the triangles, but in this case corresponding sides are not congruent. They are in the same proportion, they are in the same ratio. Ratio is 2 is to 1 here. It can be any ratio, 2 is to 3, 4 is to 5, any ratio, but then the same ratio is maintained between all the pairs of corresponding sides. This is the second test of similarity of triangles. It is side test. Now we will go to see the third test. Students, in the third test, which is called as side angle side test, I have not drawn a separate figure. Why? Because I can use the same figure which is used for second test, that is side test. What I will be doing is, suppose I remove this measurement. Okay, the measurement of this pair of corresponding sides I removed. Now I can see that side PQ and side LM are in the ratio 2 is to 1. Side QR and side MN are in the ratio 2 is to 1. Now only two pairs of the corresponding sides are given in the proportion. So they do not make the sufficient condition for the test. Now for this test, if suppose we are given the included angle Q should be, if it is given angle Q congruent to angle M, the angles are given congruent. Remember, then the triangles are similar by side angle side test. Please remember, the angle should be the included angle. That's why letter A comes in between S and S. So these two sides are in proportion, and the included angle, the angle that is formed between these two sides, the sides which are in proportion are congruent. Angle Q congruent to angle M. So this is the third test, which is called as side angle side test. Okay, all these three tests are the only test of similarity of the triangles. There are no other tests. You have studied congruency of triangles in 9th standard, but in congruency of triangles you have studied totally 5 tests of congruency. Remember, do not clash with this test of similarity and the test of congruency. Test of similarity of triangles are only 3: angle test or angle test, side test, and side angle side test. Based on this, you are given problems in practice set 1.3. So this is the theory part of practice set 1.3. Now one more point is left before we start the practice set 1.3, and that is the properties of similarity of triangles. So students, you see, properties of similar triangles. Not the properties of similarity of triangles, properties of similar triangles. The first property, reflexivity. Second property, symmetry. The words sound to be very familiar to you, right? Third word is transitivity. Okay. Now recall 9th standard, you had seen similar properties, but of congruent triangles: reflexivity, symmetry, and transitivity. Reflexivity says every triangle is similar to itself. That is, triangle ABC is similar to triangle ABC. Symmetry says if one triangle is similar to a second triangle, then the second triangle is similar to the first triangle. That is, if triangle ABC is similar to triangle PQR, then triangle PQR is similar to triangle ABC. And similarly, we can write transitivity also. What is it? If one triangle is similar to a second triangle, and the second triangle and the second triangle is similar to a third triangle, then the, याद करो, remember that, then the first triangle is similar to the third triangle. So it's very simple. We can write example also. How did we start here? If triangle ABC is similar to triangle PQR and triangle PQR is similar to triangle XYZ, then if this is the condition, then first triangle, that is triangle ABC, will be similar to triangle XYZ, that is the third triangle. So these are the three properties of similar triangles: reflexivity, symmetry, transitivity. These properties are sometimes used in the problems. Mostly transitivity is used. Okay, and how they will be used, we will see while solving the sums of practice set 1.3. So practice set 1.3 is based on these two things: one, the test of similarity of the triangles, and two, properties of similar triangles. Most of the part of practice set 1.3 is based on the tests of similarity of triangles, that is AAA test or AA test, second SSS test, and third SAS test. So now we shall try to do the sums based on these two theories. So students, you see in the first sum of practice set 1.3, we are given this figure. In the figure you see that angle ABC is 75 degree, and you see smaller triangle within bigger triangle, and angle EDC is of measure 75 degree. So angle ABC equal to angle EDC equal to 75 degree. Now they have asked us that with reason find out if both the triangles are similar to each other or not. Okay, and we have to state the test of similarity if the triangles are similar. So we will solve this sum. How to solve this sum? We write, be very careful. Okay, this is a simple sum but very important sum. How to write the names of the triangles? Listen carefully. How to write the names of the triangles so that their vertices will be in one-to-one correspondence with each other. If I prefer to write the name of bigger triangle as triangle ABC, then the other triangle, how should I write the name of the other triangle? So for that you must know that the vertices of the two triangles should be in an order that we call as one-to-one correspondence of the vertices of the triangle. So if I start the name of triangle, big triangle ABC from vertex A, then how should I start the name of the other triangle? It will start from vertex E. Okay, now from vertex A I go to vertex B. So from vertex E I have to go to vertex D, and from A to B, after going A to B I am going to C. So here I have to go from E to D to C. So you have to write the names of the triangles. Very important part. In the first line only, the people, the examiner, the moderator or the teachers will come to know your intelligence, your sharpness of the brain. In triangle ABC, if I write, and then I will write the name of the triangle, but I will have to be very careful. I have to see that one-to-one correspondence of the vertices is maintained. So in triangle ABC and triangle EDC, what do we see? In these triangles, which are the equal parts, which are the congruent parts? Angle ABC is congruent to which angle? So it is angle EDC. Reason is given because both the angles have same measure, 75 degrees. So they are congruent. And you see that which angle is common angle? Angle C. We can write angle ACB congruent to angle ECD. Okay, or only we can use single letter, but let us prefer to write angle ACB, three-lettered name of the angle. Angle ACB congruent to angle. Since I started with A, I will have to start with E here. So angle ECD. Reason common angle. What is the reason? Common angle. Now what I have? I have two angles of this triangle ABC congruent with two angles of other triangle. That means just we studied, the test of similarity. That means the two triangles, triangle ABC will be similar to triangle EDC by which test? By which test? The test will be angle test. So yes, everything is there in front of you. With reason, we have to find if both the triangles are similar to each other or not, and if they are similar, then by which test. So yes, we can say that the triangles are similar to each other. By which test? Angle test. Why? Because two angles of one triangle are given congruent to two angles of other triangle, and we have a provisional test, AA test, angle test, which is a part of triple A test, that is angle test. This is how very simply we can solve the first sum. Now we go to solve the second sum. So students, in the second sum, they have asked us the question, are the triangles in the given figure similar? If yes, by which test? If you remember properly, I had given such diagram to explain you the side test. Now you can see that similar figure is there. Here in triangle PQR, the three sides are given of length 6, 8 and 10 units, and in the smaller triangle LMN, the three corresponding sides are given as 3, 4 and 5 units. Now let us see corresponding side PQ and LM. If they are the corresponding side, then what is the ratio of their lengths? 6:3. That is 2:1. This also is 2:1, 8:4:1, and 10:5:1. So we see that corresponding sides are in same ratio. So yes, triangles are similar. Understand? By which test they are similar? They are similar by side test. Very simple. Now how to write the answer to this question? See, how to write? In the solution we write ratio of side PQ to LM. PQ upon LM is 6/3, which is 2/1. Result number 1. Second pair of corresponding side. Ratio QR to MN. What are the lengths? 8/4. What is the ratio? 2:1.